Today we're going to work on exercise 1D, which is going to be a recap of solving linear equations. You've done some of this in year 9, and so we're going to have a look at what you will have been told in year 9, how you're then going to look at applying this, okay? Where you did a whole unit on solving equations in year 9, we're doing one lesson now, okay? So it's going to be up to you to make sure that you understand what's going on. Make sure you're coming to Maths Help or you're asking lots of questions, James, if you are not sort of finding that this is as straightforward a process as what it needs to be for you at this point, okay? So some key learning intentions for you today. We're going to be solving linear equations when there are brackets. You've been doing some expanding of brackets over the last couple of lessons. When there are unknowns on both sides of the equation, and when there are algebraic fractions involved. The other thing then we'll look at doing is teaching you how to use the solve function on your CAS. So your CAS will solve all of these things for you and make that a pretty easy way for you to look at checking your answers. Okay, so just some notes on linear equations to start with. So just reading through these. A linear equation describes a relationship that when plotted on a Cartesian plane produces a straight line. So toward the end of last year you will have looked at doing a lot of that straight line graphing stuff. This is the equation that you're looking at graphing, okay, a linear one. Anything that's a linear equation, the variables are to the power of 1. So for example, if you've got 3x plus 2y equals 6, the x is to a power of 1 and the y is to a power of 1. As soon as you're dealing with squareds or other things in this, it's not going to be a linear equation anymore, okay? And we deal with some stuff that's not linear a little bit later in the year. Equations show the equivalence of two expressions. So if we have a look at these two parts of this particular expression above here, we've got an expression 3x plus 2y and we've got an expression just 6. Okay, we're showing that these two things are equal to each other, all right? Being able to, I suppose, work with different steps of an equation, you are using equivalent expressions to be able to work this out, okay? And we're going to have a look at the steps you can take to do that as we continue to work through. Equations can be solved using inverse operations, so using our balance method. We went through this pretty well in depth last year. Some of the working out and stuff that you had to show last year, we're going to streamline that now. We're not going to expect you to show as much of the thinking. We're just going to go straight from one step to the next step and so on. So we'll have a look at what that looks like for you in a couple of worked examples. Just to recap, if we're talking inverse operations, what's an inverse operation?
Addition and subtraction.
So if you see the word inverse, what does it mean?
It's the opposite.
Yeah, opposite, okay? Inverse means opposite. So to solve equations, we're looking at doing the opposite thing to what you can see there. So if we're adding something, we would be subtracting. If we're multiplying, we would be dividing. If we're raising to the power of 2, what's our inverse or our opposite to squaring something?
Root.
Yeah, square root, okay, good.
What's a surd?
Okay, so as you're working through solving equations, looking at particular types of operations that are happening, you're doing the opposite to the operation that you can identify. So to solve an equation, the last operation performed on the pronumeral is the first operation undone or cancelled out by performing inverse operations on both sides of the equation. So first of all, what we're going to have a quick look at doing is looking at this particular expression here, 2x plus 3. What are the operations that are being performed on your x here? What can we see happening to it? Ignore the equals 5.
Multiply.
We're multiplying by 2 and adding 3. So we're going to multiply by 2. The 2 is here. So we're multiplying by 2. This is happening first. So when you're thinking about this, it's 2 times that number x, then you're adding 3. So the first thing that happens is we're multiplying 2, then we're adding 3. All right? So you're thinking about when you look at this equation, what operations are happening, what order they're happening in. We then reverse the order and do the inverse or the opposite, okay? So because we're adding 3 last, the first thing we're going to do inverse operations to solve is we're going to subtract 3, okay? Second thing we're then going to do is we're going to divide by 2.
Wait, so you do them in the
You do them in the opposite order, okay? So when you look at this, you start with x, you multiply it by 2, you add 3, so we subtract 3, then divide by 2, okay? So looking at that as, I suppose, our way of thinking about this particular question, 3x plus 5 equals 20, what I would have got you to do if you were in my class in year 9 last year, is we would have looked at this same as up here, we're adding 5 and it's the last thing we do, so we would subtract 5. All right, so we'd have 3x plus 5 minus 5 equals 20, take away 5. All right, we're doing this to both sides of our equation. All right, and I would have wanted you to show me this particular step. What happens is you can cancel those two parts here out because plus 5 minus 5 equals 0. And you would have got that 3x is equal to 20 take 5, which gives you 15, okay? Now we can do the multiplication. We can reverse this, or we can use the inverse. So 3x divided by 5, and we get 15 divided by 5, okay? Because we're doing the same thing to both sides. Dividing by 3, not 5. Yeah, dividing by 3. So 3x divided by 3, what that's going to do is it's going to cancel out your 2 3's on this side of the equation, and we're going to have x over here. 15 divided by 3 gives us 5, 3 divided by 3 gives us 1, and so x is equal to 5, all right? What I'm going to get you to do this year, the working out you're going to be looking at showing me, you don't need to put this step here in, and you don't need to put this step here in, okay? It's going to be perfectly acceptable for you to write out your question or your equation you're solving to start with. If we take 5 from both sides now, rather than writing this step out, we can just jump straight to this. Because what you can see here, we've taken 5 away from here, and we've taken 5 away from here. So 3x equals 15. We've skipped this step and just jumped straight to this one. Next, after this, we can divide through by 3. So dividing 3x by 3, we get x. Dividing 15 by 3, we get 5. So rather than doing that in 5 lines, you can now get to the point you can do this in 3. I'm not concerned as much with whether you can show me you can balance an equation, you just need to be able to do the steps to solve it. So just showing me each of those different steps is enough working out to show now, okay? We're going to be much more concerned with why you're actually solving this as opposed to the process you're taking to solve it.
Yeah, but can you do 5 lines if you need to?
You can do 5 lines if you need to, by all means, but we want to work on getting you to the point where this is the working out you can show for this question. Okay? Any questions on that thus far? Anything people aren't sure about? Happy to move on? Okay. Next bit we're going to have a look at is where you've got brackets in equations. Okay, and sometimes brackets can be involved in solving equations. You may be able to cancel out expanding the brackets as the first step, or you may need to expand the brackets and then simplify down. Okay, so there are 2 different things that you can do for this. The check to see whether you expand the brackets or not is to see what happens if you divide through by the coefficient of the bracket and whether you are going to get a fraction. Okay. So what we're looking at first is this number that's outside the fraction, it's multiplying your bracket, okay? Our order of operations tell us that if you are working with brackets, you do what's in the brackets first. So whatever's happening in here occurs first. After we've done this, then we multiply by 3, all right? So because the multiplying by 3 happens last, here what we can say is 3 multiplied by 3x, all divided by 3, is equal to 12 divided by 3, okay? 12 divided by 3 is going to give us a whole number. It's going to give us 4, okay? If we apply the same thing to the second question we're going to look at over here, what that's going to give you is 2 divided by 3. You're going to be dealing with a fraction, okay? So in this particular instance, if you're going to deal with a fraction by dividing through by the number outside your bracket to start with, you can choose to expand the bracket first so that you don't deal with fractions, okay? It makes it a little bit easier for you, all right? So with this one, we're going to divide through by that 3 to start with, and it cancels it out. And over here, we're going to be left with 4. So we're going to be left with 3 minus x being equal to 4, and we can now solve this as a simple linear equation, okay? We're adding 3 to this equation to start with, so we're going to subtract 3 to cancel it out. So subtracting 3, we're going to get we're going to cancel this 3 out, and it's going to be 4 take away 3, which is going to give us 1. When you get something that looks like this and you've got a minus x, do you leave it like this or do we keep going?
Keep going.
We keep going. Why do we want to keep going? We want x, not minus x. Okay? What do we do to change minus x into x? You could add x and it would make it equal to 0, but then it's also going to add x to this side as well. So you're going to end up with x's on both sides. We do. We multiply by -1. Okay? And if you think about what happens if you multiply by -1, if you multiply anything by 1, what do you get?
You get 1.
You get the same thing, okay? Because we're multiplying by -1, the two negatives are going to cancel out here. Two negatives make a positive, okay? So minus x times -1 is going to give us positive x.
I get rid of the 3.
The 3 here, we took away 3 from both sides, okay? So we looked at, in this one, we took away 3. 3 take away 3 cancelled it out. 4 take away 3 gave us 1, okay? When we get to here now, we've got 1 times -1. 1 times 1 is just going to give us 1. A positive and a negative is going to turn this into a negative. So x is going to be equal to -1. All right. Now on this side, as we talked about when we looked at this bit here, if we divide through by 3 to start with, like what we did with this particular equation, we're going to end up with x plus 2 equals 2 over 3. And we don't really want to work with fractions, okay? We want to make it a bit easier for ourselves. So first thing we're going to do is we're going to expand this bracket, all right? So that check when you get one of these types of questions involving brackets is you can divide through by what's in front of the brackets to start with, but you only want to do that if you get a whole number, like we did here. We got a 4, okay? Because we're getting 2/3, we're going to choose to expand the bracket instead. Expanding this bracket, 3 times x plus 2. What's that going to give us if we expand it out?
3x plus
3x plus 6. Good. So 3x plus 6 is going to be equal to 2. Now we can look at just cancelling parts of this out in the same way and working through to get our answer. So 3x plus 6, we're going to want to take away 6 from both sides. So taking away 6 from this side gives us just 3x. Taking away 6 from 2 is going to give us what? -4. Now we've got 3 multiplying our x, so we're going to do the inverse of that, or the opposite of that. We're going to divide by 3. 3x divided by 3 gives us x. -4 divided by x gives us -4 over 3. Okay? A lot of these things are going to work out giving you fractions in the end, so don't get too stressed if you end up with a fraction at the end. It's much better to get a fraction on the last line of your working out though than what it is to have to work with it from the beginning. Okay? So if we can avoid fractions early on, that's always preferred. Thomas.
How do you go from the second sentence?
So from here to here,
No, take away 6 from middle to the one.
this one to this one,
No, the middle one
yeah,
to the last
that one to there, we divided by 3. So this is 3x divided by 3 gives x, it cancels out the 3. -4 divided by 3 gives you -4 over 3. Okay? All right. Next thing that we're going to have a look at is solving equations where you have pronumerals on both sides. So first step when pronumerals on both sides of the equation is to collect all of the pronumerals on one side. All right. So rather than having an x on both sides of your equation, it's just going to be on one side. Note when you're doing this, I suppose it's convention to write the term with a pronumeral on the left-hand side of an equation when providing a solution. So if you're working down and your x ends up on the right-hand side, when you get to writing your solution, we just flip the way we write it, okay? So we'll have a look at that. I think there's an example here that goes through that in a sec. How do you choose which one it is that you're going to take away, or which one you're going to try and cancel out? Okay, what you're looking for is the one that has the smallest value. So it's either going to be the smaller of the two numbers, or if one of them is negative, that's automatically going to be smaller than one that's positive. All right, even if the number is bigger, -6 is smaller than 2, for example. All right, so we want to try and cancel out negatives where we can. So after we choose which term we're going to do, we're going to use an inverse operation to cancel it out. So looking at the first one we've got here, 3x plus 7 and 2x plus 13. Which one's going to be our smaller term?
2x.
The 2x, okay? So if we're looking at 3x plus 7 and 2x plus 13, what we're going to do is we're going to take away this 2x from both sides of our equation. So we've got 3x plus 7, and you can take away 2x from this side, and we're going to have 2x plus 13, and we're going to take away 2x from this side as well. Okay.
So then it's x plus 7 equals 13.
And so these two x's are going to cancel out on this side, and as James has just told us, we've got x plus 7, and that's going to be equal to 13. So now we're just going back to those equations we just looked at solving, where your pronumeral's on one side, okay, and you're working through to try and solve for x. So next step, what would we do here to finish this one off?
Wait, how did you get x plus 7 though? What happened to the 3?
The 3 and the 2, when we collect those like terms, they give us x. Yep. So 3 take away 2x gives us x. We've got a plus 7 left over, and there's a 13. Okay, because these two 2x's cancel each other out. One's positive, one's negative. All right? When we get to this line here, we just want x equals. So instead of x plus 7, what are we going to do to make this just x equals? We're going to take away 7 from both sides. So if we have x plus 7 and we take away 7, it's going to cancel this bit out. And over here, we've got to take away 7 as well. It's going to be 13 take 7 to give us 6. Okay. Do people want to see these at the moment with some of those intermediate steps still written into them? Are we going?
Yeah, they'll be.
Okay, we'll do the next one. We'll write all of the steps in so you can see what's happening.
Why do you get rid of
The 3 here,
not below that?
underneath here, because we've got 3x and we're taking away 2x from it. So 3 take 2 gives us 1x, which is just x. Okay. If we come to look at example number 2, we are going to cancel the 2 because the 2x is the smaller one. We're cancelling the x first. Because we've got a pronumeral on both sides, we work with the x. We want to get that all on one side. So in this one, pardon? Yeah, we do the pronumeral first if there's a pronumeral on both sides. So we're going to cancel this positive 2x out by taking 2x away. And we're going to get 6x plus 1. And again, we need to take away 2x, okay? So we're doing this on both sides of our equation, all right? All up now, what looks at happening here is we get these two 2x's cancelling each other out because one's positive and one's negative. And we've got negative 7 left on the left-hand side of our equation. What's going to be on our right-hand side?
4x plus
4x plus 1.
Good, 4x plus 1, okay. Now, this is where, when we get to our answer, at the moment we've got our x term on the right-hand side, but our note up the top up here says that it's our convention to write our pronumeral term on the left-hand side. So you can wait until the end, or you can flip these things around now, and you can say that 4x plus 1 is equal to minus 7, just so that for that convention, you've got your x term on the left-hand side, okay? Because these things are equal, it doesn't matter which way around they are written. You can swap and change these things as much as you want because it's still equal to the same thing, okay? From here, we want to try and cancel this part here down now. So what's going to be our first step to try and cancel this down more?
Cancel the 1.
Cancel the 1. What are we going to do that, James?
Take away 1.
Take away 1.
Yes, Harry.
All right, so 4 plus 1 and then take away 1 equals minus 7, and we've got to take away the 1 from that side as well, okay? What that lets us do is cancel out our 2 1s, and so that's going to give us 4x, and on this side of our equation here we've got minus 7 and we're taking away minus 1. So we're going to get negative 8, good. What's going to happen next? Dividing by 4, good. So 4x, we're going to divide by 4. Because we're dividing the left-hand side by 4, we're also going to divide the right-hand side by 4. Those two 4's can cancel each other out now, that's why we're dividing by 4. So it's going to give us just x minus 8 divided by 4.
-2.
It's going to be a negative, good, and it's going to be 2. Okay?
Is it going to be positive 2?
Negative 2. This is negative 8 here, and we're dividing by positive 4. Negative and positive make negative, and 8 divided by 4 gives us 2. Okay? Anything that people want to ask about for this one?
What happens when you check the bigger number? Do you end up with negatives?
You end up working with negatives, yeah.
I think it's easier with more steps.
The more steps? Okay, so if you want to, I suppose, I'll work through putting more steps in so that you can see what's happening, but ultimately what...
Like the second one without less steps.
Pardon?
When you do the second one without, it's usually compared both of them.
Yeah, okay, so you want to do the first one with more steps, second one with less steps?
One of the two.
Okay, righto. You want me to write this one out where we don't have all of the intermediate steps there? So if we were looking at doing that, what we'd have is we started with 2x minus 7 equals 6x plus 1. And what we're doing here, we're going to take away 2x from both sides to start with. So we're going to get minus 7 is equal to 4x plus 1. Then we're looking at adding taking away 1 from both sides to cancel out this minus 1. So we're going to get minus 8 is equal to 4x. Okay. And from there, we're now going to divide through by 4. So we get minus 2 is equal to x. And just to finish that off, x is equal to minus 2. So our pronumeral is on the left-hand side.
Is it the same steps?
It's the same steps, I'm just not showing that intermediate working out that you're kind of thinking when you do it, okay? So if you need to do all of this stuff to start with, that's fine, okay, and write that out, but we're aiming to get to the point where you can do this, because you really need to be able to do it like this when you get to year 11 next year, okay? So if you need to start off doing this like we've done in year 9, that's fine, and then we work on trying to, I suppose, cut those steps down as you go, okay? All right, last bit that we're going to look at, solving equations when you're looking at using algebraic fractions as well. So we've been doing a little bit of work with some algebraic fractions. We're going to bring that into some equations. When you're working with equations that are going to involve fractions, first step that we want to try and do is cancel out our fractions so we're working with whole number terms. All right, it's really messy to work with fractions when you're doing this. And so we want to try and find a lowest common multiple of all of our fractions, multiply through so that we're dealing with whole numbers, all right? So first one that we're looking at here, it's incredibly frustrating when people are having side conversations. First thing that we're looking at is our two fractions. So we want to try and find the lowest common denominator of both of these fractions, or the lowest common multiple of both of these fractions, so that we can multiply through by that and cancel the fractions out. So smallest number that both 2 and 3 go into, 6. Good. So we're going to multiply both sides of this equation now by 6. Okay. So that's our first step. We're going to cancel out these fractions. Expanding this bracket, 6 times 2x gives us...
Is that 6
12x.
Yeah, okay.
12x plus 3.
So we're going to get 12x here. And then 6 times a half
3.
is going to give us 3. So that side is going to become 12x plus 3. Over here, if we multiply 6 by 2/3, what do we get as a fraction for this? So if we just think about what this might look like,
Is it 12 over 3?
it is going to be 12 over 3. What we're looking at is 6 over 1, and we're multiplying this by 2 over 3. 6 times 2 gives us 12, and 3 times 1 gives us 3, okay? Working with our fractions now, 12 over 3, what can we equate this to? 4, okay, good. So you can work this through in your solution if you want, or if you can multiply 6 by 2/3, you can just write this down on your page as 4, all right? And now this just becomes a linear equation like what we have been solving, okay? We're looking at taking 3 from both sides, okay? Do you want a full solution, or are you happy just to...
Yeah,
You want the steps in between? Okay. So if we're looking at 12x plus 3, we're taking away 3 from both sides. And so we're going to get 12x. Those two parts there are going to cancel out. And it's going to be equal to 4 take 3, which gives us 1. If we now look at dividing both of these sides by 12, because we're multiplying our x by 12, we're going to get that x is equal to 1 over 12. Okay. So this is one method that you can look at taking to help solve this particular question. Okay. What was our other method for being able to cancel out denominators in fractions that we looked at the other lesson? We were multiplying by what in a smart way?
Fractions. Was it fractions?
Yeah, so we looked at something like,
One, was it?
yeah, okay. We looked at something like 2 over, no, that's probably not a good example. But we were looking at multiplying by 1, okay? But we used a version of 1 that had a denominator in it that lets us sort of cancel something out. If, why am I talking about that? No, we're going to take the same method. We're going to do the same thing here. Again, looking at our two numerators, so scrap that idea. If we're looking at our two numerators here, what's our smallest number that both 5 and 3 are going to go into? 15. So we're going to multiply both sides of our equation now by 15. Okay, so 15 times 3x plus 1 over 5. Take away 4. And 15 times 10 over 3. Okay. When we're dealing with fractions, rather than writing this as 15 times 10 over 3, it can always be a good idea to turn 15 into a fraction too. So make this 15 over 1. What that lets us do is if we work with this part here first, we can cross cancel across this, okay? 3 divided by 3 gives us 1, 15 divided by 3 gives us 5. So we can cross cancel across our fraction there and make that multiplication a little bit easier. Up in here, same thing's going to happen. We're going to multiply this first term by 15. So we're going to get 15 multiplying your 3x plus 1 all over 5. And we're going to get 15 multiplying 4. Okay? And all up on this side of our equation, we've got 5 over 1 times 10 over 1. So all we've looked at doing here is take our 15, multiply this 3x plus 1 over 5 by that 15, multiplying the 4 by the 15, and then here we cancelled a common factor of 3 out just to make our multiplication of our fraction a little bit easier. Okay. What we can look at doing with this part now is you can take a common factor of 5 and cancel it out. So 15 divided by 5 gives us 3. Yep, it's okay. So 15 divided by 5 gives us 3. 5 divided by 5 gives us 1. Okay. What that's going to let us do now, we can multiply that bracket with a smaller number than 15. I'll give you a sec to catch up. So here what we're looking for a common factor between 15 and 5. Biggest number that goes into both is 5. All right, so we divide both numbers by 5. 5 divided by 5 gives us 1. 15 divided by 5 gives us 3. Okay. All right, so as we're... the 4 up here, we haven't got rid of it yet. We're just multiplying the 15 at the front of the brackets out. So it's 15 times 4.
Do we
Okay.
expand the bracket?
Yeah, that's what we're doing. We're expanding the bracket here at the moment. Okay, so now what we've got on our next line, we can have 3 times 3x plus 1, and 15 times 4 gives us 60, and over here, 5 times 10 gives us 50, and it's all over 1, so it will give us 50.
Yeah.
Okay, so now we've got rid of our fractions, and we can just work at cancelling this down as we have been. So if we're looking at expanding this bracket out, 3 times 3x plus 1, what will that give us?
9x plus 3.
9x plus 3. And then we've got take away 60. We haven't done anything with this yet. It's just going to stay there. And plus 50. Okay. What can we do with the 3 and the minus 60 now?
You add the 60 to 50.
Okay, so we're going to put these two together. What will it give us?
Negative.
Oh, yeah.
Negative 57. Good. Okay. From here, next step. What do we want to look at doing now?
Add 57.
We're going to add 57 to both sides.
Can you put it on the screen?
Sorry, yeah. We'll scroll down just that little bit for you. Minus 57 plus 57.
Is it 107?
It is 107. So these two are going to cancel each other out, and we've got 50 plus 57 on the other side. 50 plus 57 gives us 107. Okay. Last step to solve this one. What do we want to do? Dividing through by 9. Good. 9x divided by 9. 107 divided by 9. The 9s are going to cancel, and you get x equals 107 over 9.
So would it be negative 64?
What we've got here though, this one's plus 3. So if you start at plus 3 and then you take away 60, you're going to take away 3 and end at 0, and then you've got a further 57 to take away. Okay. Think about being at minus 60 and you're going to add 3 more onto it. So you're going from being negative, you're trying to make it more positive. So it's becoming a bigger... not for this one. This one's a plus 3. Okay.
When do you change it from negative?
If it's being multiplied by like a negative number.
So, can't go 179?
You could, but it's going to give you a decimal. Okay, so most of the time in 10A maths, we're going to ask you for an exact value. Okay, if we ask you for a decimal, put that in. It's going to be something like 11.9, I reckon. But yeah, 108 is 12 times 9, so you know that it's not going to be a whole number. Last one that we're going to look at before we do a little bit of CAS stuff is this one here, and there's actually a different method you can use for one that looks like this, that's just a bit quicker. Sorry, Aaron. Yep, there we are. So with this one, we have 2 fractions, okay? We have a different numerator. 12 is our lowest common multiple. Good, okay? Rather than use a lowest common multiple to multiply this one though, what we can actually do is we can take a bit of a shortcut, and I'll show you why that is. But we can take the 4 and put it on the other side, and we can take the 3 and put it on the other side and multiply, okay?
Also, wait, does that mean it becomes 3x plus 1?
Kind of. It's going to be 3 and the x plus 5 is going to be in brackets. All right? So as James has told us, the lowest common multiple is 12. So if we multiply both sides of this by 12, what we get is this. So 12 outside of x plus 5 all over 4, and 12 outside of x plus 3 all over 3.
Well, after switching
We are going to switch. I'm just going to show you why you can do it, and then you guys won't have to do this step. You can just go straight to the switching.
So is this
Okay?
like explaining?
This is the proof for why you can do the trick that I'm going to show you in a sec. Okay? So here, what we can look at is if this is 12, that 12 is going to multiply x plus 5 over the 4, and the 12 is going to multiply the x plus 3 all over the 3. Now what we can do is, there's a common factor for 4 and 12. What is it?
3.
4 is going to be our common factor, and it's going to give you 3. Good. So if we divide 12 by 4, we get 3. Divide 4 by 4, we get 1. Over here, if we divide 12 by 3, we get 4. Divide 3 by 3, we get 1. So we can take a common factor out of both of these things. And what you end up getting is this. Okay? And so what you can actually see happening is the 4 that was in our original denominator here, it goes to the other side and it multiplies the numerator. And the 3 that was on this side comes up here and it multiplies the numerator on this side. So you guys can skip this particular step and jump straight to this, okay? It's called cross multiplying. It's a particular method you can use to solve it. It's when you've got just 2 fractions with different denominators on both sides, you just multiply the numerators by the other side's denominator.
Can you leave it up 1 minute?
I can leave it there for a sec for you, yep. If we work out this one from here now, we get 3x plus 15 and 4x plus 12, expanding both of these brackets. So 3 times x and 3 times 5, 4 times x and 4 times 3. And now this becomes one of the ones where we were solving something on both sides of the equation. Okay, so this is something you can look at finishing off. Rather than finishing this algebraically, I'm going to show you how you can do this on your CAS to get us an answer. Okay, so can you have your CAS up and on your desk, please? Go into the edit menu and go clear all variables and clear all, just so that we know we're dealing with a completely blank main mode. And this one's going to cover a really important function of your CAS for you. It's called the solve function, and you can just put in equations and your CAS will spit out an answer. So it's a really useful thing, whether you stick to 10A and doing methods stream or whether you go into further stream, you use this particular function in both of those streams of maths. Okay? So what I want for you to do, go to the menu button, go to main, choose the keyboard, okay? And on the Math 1 menu, if you're not in it, just push Math 1. You should be able to see this keyboard. Just have your hands on your head or put a hand on your head when you can see this keyboard. So if you can't see a CAS at the moment, look on with someone that has one, please. Okay. On the 3rd row, right on the right-hand side here, there is a function called solve. Can you push it? And it will put solve with a bracket onto the first line of your main part of your CAS. Once we have solve here, we're going to enter this particular equation in. So x plus 5 over 4 and x plus 3 over 3. So the solve button is just over here. 3rd row down, right on the right. X plus 5 over 4 and x plus 3 over 3. Okay, once you've entered this in, part of the syntax for a solve function is you need to tell it what variable you want to solve for. Okay, actually this is an equals. We want an equals in the middle. Okay, so it needs to have an equals sign, it needs to be equal to something. Then you need to tell it it's on the top left-hand corner of your keyboard, like your actual physical keyboard. So once you've got this, put a comma in, please. The comma is down the left-hand side of the physical part of your keyboard, the button, the comma button, and then push X and put a bracket. Yes.
So what's that little dot next to there?
It's a comma. If you go down the left-hand side of your buttons and push the comma button.
Okay. Do you press execute?
Now, with this particular thing, what you are doing here, this first part, you're putting in what you're getting your CAS to solve for you. Okay? The syntax of this is you need to tell it what to solve for. So you put in a comma and then you enter the variable that it's solving for. We're solving for X here. Then you close your bracket. Okay? If you push execute now, it will give you an answer for X.
Yeah.
All right? If you're dealing with fractions, okay, and it gives you something like a decimal, so 1.33333, You want to go back and make sure that you've turned decimal mode off down the bottom here and you've turned standard on, because it should give you something like 4/3. We want fractions rather than decimals. Okay? It does have show decimal for me. You can push that and turn it to standard. Okay? So that's solve mode on your CADs.